Well, here we are to our final review. So we'll talk about parametrics and conic sections. So first we're going to find parametric equations for a circle with center -3, 4 and radius r equals 5. So hopefully we remember we're going to say x equals -3, the x coordinate, plus the radius 5 times cosine of t, and y is going to be 4 plus the radius 5 times the sine of t. And those are our parametric equations. Then we're going to eliminate the parameter. So let's remember our favorite trig identity. Sine squared plus cosine squared is equal to 1. And then from that, if we divide through by cosine squared, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So we are also going to use the identity secant squared t minus tangent squared t is equal to 1. Okay, let's do the blue problem. So we're going to subtract that 3 to the other side. So that'll give us x minus 3 is equal to 4 cosine t. And dividing through by 4, we'll get x minus 3 over 4 equals cosine t. Similarly, we'll add 1 and then divide by 5 and get y plus 1 over 5 is sine of t. We'll then use our trig identity and get the x minus 3 over 4 squared. There's our cosine squared. And the y plus 1 over 5 squared, that's our sine squared, must equal 1. We'll split that up in square numerator and denominator and hopefully get to something that looks familiar with what we've done in the past. And hopefully we can recognize that as an equation of an ellipse. Now, in the same fashion, we're going to solve for secant. So that's going to be x plus 2 is equal to 3 secant t. And then dividing through by 3, we'll get that secant t is x plus 2 over 3. Similarly, subtracting the 1 and trying to get the tangent by itself, we'll divide by 5 to get y minus 1 over 5 is tangent of t. Then we'll plug it into our other trig identity, the one with secants and tangents. And so we'll get the x plus 2 over 3 squared, there's our secant squared, minus, here's our tangent squared, is equal to 1. And again, splitting that up into the square of the numerator over the square of the denominator will lead us to, hopefully, what we can recognize as a hyperbola. Okay, let's put into standard form and graph. So what we want here, we notice that we have a y squared but no x squared. So we're going to write this in the form of x equals, we're going to get that x by itself, x equals a times y minus k squared plus h. So I'm going to add the 1 to the other side. So we got 8x is y squared plus 2y plus 1. And then we're going to, actually I'm going to write it not in this form, but I'm going to just write it as ay squared plus by plus c. I think that's a little bit easier. We're going to go 1/8 y squared plus, that's going to be 2/8 or 1/4 y plus 1/8. Now we know that the vertex is going to, our vertex is going to have y coordinate, y equals negative b over 2a. So that's going to be a negative 1/4 over 2/8. And so that's going to be a negative 1/4. Since 2/8 reduces to 1/4, that is going to give us y equal to -1. Then we'll plug it back in for the y to find out what the x is. So -1 squared is 1, times 1/8 is 1/8. -1 times 1/4 is -1/4. I'm going to get a common denominator, and we've got this 1/8 right here. So that looks like we're going to get 1/8, 1/8 and 1/8 is 2/8 minus 2/8. Looks like we're going to get 0. So it looks like our vertex is 0, -1. So when we go to graph that, I'm going to go to 0, -1. Now this is going to be an x equals positive y squared. So this is going to open to the right. So I'm going to write the coordinates over here. That should be out of the way. Now, we can plot another point easily enough. If we plug in 0 for y, that will give us x equals 1/8. So I'm going to say right about there is 1/8. So that is going to be 1/8, comma 0. And then using the symmetry of our parabola that we know is opening to the right, there's going to be another point over here that's going to be at 1/8, comma -2. So our parabola is going to open to the right and open pretty widely. So it's going to look something like that. Now we need our vertex and our directrix. So our A is 1 over 4p, and our A is the 1/8. So taking the reciprocal of both sides is going to tell us that p is 2. So we're going to go inside the parabola, so to the right. So we're going to go to the right of the vertex, and that will give us a focus that's going to be at 2, -1. Going to the left is going to give us a directrix that's going to be x equals -2. And there's our parabola. Now the next one, the green one here, you may hopefully recognize we have an x squared and a y squared. The coefficients are the same sign and the same coefficient, so that's going to lead to a circle. So let's gather the x terms together and gather the y terms together and move the constant to the other side. We're going to, because we can, I think I'll divide through everything by 2. I think that will just make the numbers be a little bit easier to work with. And now we're going to complete the square in x. So we'll take half the middle term. Half of 6 is 3, squared is 9. And we'll add that to both sides. Half of 4 is 2, squared is 4. So we'll add that to both sides. So that gets us to x minus 3 squared plus y plus 2 squared is going to equal 25. So our center is going to be at 3, -2, and our radius is 5. So let's see, we can go 1, 2, 3, and down 2. That's going to be our center. And then we can go 5 in every direction. So going up 1, 2, 3, 4, 5 is going to put us at 3, 3. Going down 5 is going to be 1, 2, 3, 4, 5. So that is going to be at 3, -7. Going left 5 will be 1, 2, 3, 4, 5 is going to be at -2, -2. And then 1, 2, 3, 4, 5 to the right is going to be at, what would that be? 3 plus 5 is 8, comma, -2. This is going to be a challenge. Be forgiving. That's supposed to be a circle. Ugh. Some look better than others. Okay, I'm going to move this up and get it out of sight because it's kind of embarrassing. So let's see here. Now we have x squared and y squared. They're the same sign but different coefficients. So this is going to lead us to an ellipse. So again, we're going to gather our x terms together and the y terms together. And we're going to move the constant to the other side. We'll factor the leading coefficient out of the x terms. And there's 6 quarters and $1.50, so that's going to be 6x. We'll factor the 4 out of the y terms, and that'll get us to minus 4y. And now we're ready to complete the square. Half of 6 is 3. 3 squared is 9. 9 times 25 is 9 quarters, is going to be 225. Half of 4 is 2, squared is 4, times 4 is 16. So let's see, we've got 25 times x plus 3 squared plus 4 times y minus 2 squared is equal to, let's see, 25 and 16 is 41. 241 minus 141. Oh, things are looking good. We're going to divide through to make the right-hand side 1, and so we'll get an x plus 3 squared over 4 plus a y minus 2 squared over 25 equals 1. So our center is going to be negative 3, 2. So we'll go 1, 2, 3, 1, 2. There's our center. And negative 3, 2, I didn't write that correctly. Negative 3, 2. We're going to go in the x direction 2, so 2 to the right and 2 to the left. So that'll make that point on the left 1, 2, 3, 4, negative 5, 2, and the one on the right, negative 1, 2. Those are endpoints of the minor axis because those are the shortest radii. We're going to go 5 up, 5 down. So I'm going to go 1, 2, 3, 4, 5. 5 up will put us at negative 3. 2 plus 5 is 7. That's going to be 1 vertex. And going down 5, 1, 2, 3, 4, 5 will put us at negative 3. Negative 3, that's our second vertex. I'm going to try to draw that with as smooth a curve as we can. Ooh, that was not too bad. We're going to find our foci, and we know in an ellipse the relationship is a squared equals b squared plus c squared. A squared is the biggest one, and b squared is the 4. So solving for c, we're going to get the square root of 21. Now we know that the square root of 21 is going to be in between the square root of 16 and the square root of 25. So that's going to put us in between 4 and 5. We want to be on a major axis, which is the vertical axis. So we're going to count here from the center a little more than 4. So we're going to go 1, 2, 3, 4, and a little bit. It's going to put us way up here. So that's one focus. That's negative 3, comma 2 plus the square root of 21. Then we'll go down 1, 2, 3. Let's see, 1, 2, 3, 4, and a little bit. It's going to put us down here. And this focus is going to be negative 3, 2 minus the square root of 21. There we have it. Kind of want to leave that ellipse up there. It sure looks nice. Okay, but moving on. We see here that we have an x squared and a y squared, but they're different signs. That means we're going to get a hyperbola. So we're going to gather the x terms together, leave a space, gather the y terms together, leave a space, put the constant on the other side. We will factor out the leading coefficient for x. That's going to leave us with a plus 6x. Leave a little space. Factoring out the negative 4, we'll make that be a 4y, leave a space, and we're ready to complete the square. Half of 6 is 3, 3 squared is 9, 9 times 9 is 81. Half of 4 is 2 squared is 4. 4 times a negative 4 is a negative 16. So we have 9 times x plus 3 squared minus 4 times y plus 2 squared. And let's see, the negative 16 and the 81 is going to, well, let's see. We have a negative 117 and a positive 81. That's going to be, I think, a negative 36. Now this is interesting because since that right-hand side is a negative, when we go to make that positive 1, we're going to change which is the negative on the x squared term and the y squared term. So I'm going to write the positive one first. So that's going to be y plus 2 squared now over positive 9. That's going to make that be a minus x plus 3 squared over 4. And that's equal to 1. So our center is going to be negative 3 for the x, negative 2 for the y. And so let's see, 1, 2, 3, 1, 2. There's going to be our center, negative 3, negative 2. Now in the y direction, we're going to go up 3 and down 3. Those are going to be actual points on the hyperbola. So 1, 2, 3 is going to put us up here. That's one vertex. I'm going to write it over here as negative 3, comma 1. And going down 3, we'll go 1, 2, 3. That is going to be our other vertex, and it is going to be negative 3, negative 5. Now we're going to go 2 to the right and left, but these aren't going to be points. These are going to be part of our box. So 1, 2, so I'm going to go with a rectangle. That's going to give us our asymptotes. And going 2 to the left is going to put us there. And I'm going to make that part of our rectangle. Then we're going to put in the diagonals of that rectangle. Those are going to be our asymptotes, and we need to label those. So the first one here, the one going up, is going to be y plus 2, and let's see, the slope we rose 1, 2, 3 and ran 1, 2, so that's 3 halves x plus 3. And the other one will be y plus 2 equals negative 3 halves times x plus 3. So there's our asymptotes. We have our vertex was right here. It's going to approach those asymptotes. So our hyperbola is going to open up and down. We still need to find the foci, and in a hyperbola, it goes c squared equals a squared plus b squared. So that's going to be 9 plus 4, so that's 13. So we're going to get the square root of 13. We know the square root of 13 is in between the square root of 9 and the square root of 16, so we're in between 3 and 4. It's going to be on that major axis. So we're going to go on the vertical axis up a little more than 3. So we have 1, 2, 3 is at the vertex, and a little bit more is going to put us at one focus. That's going to be negative 3 for the x coordinate and negative 2 plus the square root of 13 for the y coordinate. Going down, we'll go 1, 2, 3 and a little bit is going to put us for that focus at negative 3, comma negative 2 minus the square root of 13. And I think we got it all. Very good. I think that's everything. Very nice.